towards the end-ish, right before you get to part 2. And then you also, for part 2, you have to write yes or no in the table of solubility. And so then in the video, it's going to show, once we get to that part, 4 test tubes, and then you have a weighted amount of caffeine in each test tube. And then they're going to be adding solvent to each one at room temperature, and then showing you the test tube to see if you see anything, if it's dissolved or not. Then you answer yes or no, or Y or N. And then they're going to boil the samples, and then they're going to show you again qualitatively to see, for you to decide if it's soluble or not, so yes or no. You can just put Y or N. And then they're going to cool the 2 test tubes to see if anything crystallizes, and you say yes or no if you see crystals or not. So make sure you guys are ready with that. And so here's the start of the video. I'll be going quickly through some parts because it just repeats it over and over. These are just normal Lipton teas that have caffeine. For this process, and then this is decaffeinating things. You can probably do decaf or the decaffeination of caffeine too, or coffee. Repeating the process of adding more water to the tea bag to get as much tea content out. can see the separatory funnel. We have this stopcock thing where we can release or tighten to keep the solution. So when it's horizontal like that, it tightens it so that you don't have anything flowing through. When you put it vertical, it releases the liquid, so it starts to flow down. Add the base, then add the base and then shake it and mix it well, vent it out so pressure doesn't build up, and then by the time you add the DCM or the methylene chloride to form the 2 layers, you have the transfer. You keep the gallic acid that has been deprotonated and converted to a salt in the aqueous layer, so it stays there already. Now this is the first addition of DCM or methylene chloride or dichloromethane. Start to see that it goes to the bottom. And then the formation of the 2 layers. Done a couple of times to mix and then vent and turn it back on its right side. Wait for the separation and the settling, and you'll see the 2 layers form again. emulsion occurs when you have that some compounds that are 1 foot in the aqueous, 1 foot in the organic phase. So you want to try to separate them as much as you can. Goes to show that you have compounds of gallic acid that might still be in the organic. So that's why you see some dark spots in the organic layer. That's where the importance of the base comes in hand. And then even though you do separate it, you can see a much better separation now. You still have some amounts of the aqueous looking portion in the organic. It's not completely clear. And so then to help facilitate that, you can add some more ions such as sodium chloride to help break that down so that you are you're adding counter ions to any of the gallic acids that have been deprotonated. So you want to make sure you have enough ions for your salts so that they can go to the aqueous. And then later on, once you collect your organic aliquots, this is where you add in the drying agent, which will absorb the aqueous, trace amounts of aqueous compounds, and then form another emulsion in the organic layer, and then you can set that with gravity concentration. So now it looks a little bit better. Still not perfect, but it's good enough to do the extraction of the separatory funnel. One of the more important organic chemistry glasswares that we will use. I pretty much use this all the time in my own work, so a really important technique to learn. So this is where you're going to drain the bottom layer and then collect it multiple times. So what's going to be shown is that he's going to drain the organic layer, and then he's going to repeat the process by adding more DCM back into the top of the separatory funnel. So there he's loosening the bottom portion to allow the flow of the bottom layer. So now you just see the one layer there after the organic layer has been drained down. There's the organic layer. As you can see some brown spots that are from the aqueous, and then we can take care of that later by using drying agent. So then again, this is just a repeat of what has already been shown. Another 10 mils of DCM. You add the DCM, you start to see this bottom layer forming. So we do this to get as much caffeine as we can into the organic layer. We want to saturate the organic layer with a lot of caffeine to be able to crystallize. So repeat, shake and vent to reduce the pressure. If you don't vent it out, and when you turn it back to the right side, the cap might fly out. This happens a lot, very, very frequent. If you don't let it vent, because there's too much pressure building up. You also want to remove it to allow the separation. If you don't remove the cap, you won't see the separation go very well. That's something that. So let's repeat this. NaCl is added to the solution to help the separation. Solution was shaken, swirled, and vented, so it's a repeat of everything. Lasts for 15 minutes, and then again he goes back to draining the organic layer. Again, you can still see it's much better than the first time, but you can still see some aqueous trace amounts around right here, not even by the line, but that's okay. He's releasing this to allow flow. It's slowly going down. Now we're going to add the drying agent, which is the sodium sulfate. And again, this absorbs all of the trace amounts of aqueous components from the organic layer that you don't want there. It's going to absorb it, forming a clump. And you can separate that clump with all the aqueous, trace amounts of aqueous chemicals into, you can filter it out with gravity filtration to separate it from your organic. So there's the clumping that you can see there, and you can separate that. So this drying agent makes you be able to purify this organic layer even more. This is, hold on, let me go back. This is the weight of the beaker by itself. So this is going to be for your percent recovery. This is the weight of the beaker, 65.637 grams. And this is going to be the weight of, and the next portion is going to be the weight of the beaker with your compound. So you guys have that, and then later in the video, right before part 2, is going to be the weight of the beaker with the caffeine. So he's going to do the gravity filtration to remove the clumping of the drying agent with any of the aqueous amounts, and then you should have in the bottom of the beaker the filtrate, which should just be organic. As you can see, it's very clear. No signs so far of any unclear chemicals or compounds. Just keep doing this until you get everything out. Then, because you have too much solvent, you're going to evaporate it a bit. So again, this is still DCM.